Welcome to The Explainer. We're always trying to break down complex stuff, and today we're tackling a big one. We're going to deconstruct the Vertica analytics engine to really understand how it pulls off incredible speed at a truly massive scale. I mean, that's the big question, right? It's a huge challenge that so many modern applications are facing. And the answer? Well, it's not just about throwing faster hardware at the problem. It's about a completely different way of thinking about database architecture. So that's what we're doing today. We're going on a journey deep inside the Vertica engine to really pull it apart piece by piece. We want to see what makes it tick, why it's considered one of the absolute highest performing analytical databases out there. All right, you ready? Let's dive in. Okay, so here's our game plan. We're going to start high level, looking at what makes it an analytics engine. Then we'll zoom into the cluster architecture, talk about its secret sauce, columnar storage, and projections. After that, we'll see how it handles data in motion with the query optimizer, and finally, we'll look at the automated janitor that keeps everything running smoothly. All right, first things first. Before we get into the nuts and bolts, what does Vertica even for? It's not your everyday database. It was built from the ground up for one specific job: online analytical processing, or OLAP. We're talking about really complex queries, massive datasets, and a serious need for speed. And to achieve that speed, it's built on a few core principles. You're looking at them right here: massively parallel processing, columnar storage, aggressive data compression. But I want you to think of these less as a feature list and more as, well, the architectural pillars. Everything we're about to talk about supports these core ideas. They all have to work together to crunch through those huge queries. Okay, let's get into the first big piece of the puzzle: the cluster architecture. How does Vertica actually scale out? I mean, you can't handle petabytes of data on just one server, right? So Vertica's answer is something called massively parallel processing, or MPP. So what is MPP? The core idea is basically divide and conquer. Instead of having one giant super powerful server trying to do all the work, Vertica uses a whole cluster of machines. We call them nodes. The data gets spread out across all these nodes, and when a query comes in, every single node works on its little piece of the problem at the exact same time. It's this scaling out that's absolutely key to its performance on huge datasets. Now, this is where it gets really interesting. Vertica doesn't just have one way of doing this. It actually gives you two different deployment modes. On one hand, you've got enterprise mode. Think of this as the classic shared nothing setup. It's perfect for on-premise data centers where you control everything. Each node has its own storage, and compute and storage are locked together. But then you've got Eon mode, and this one is a whole different beast, designed specifically for the cloud. Yeah, Eon mode is built for the cloud. The big idea here is that it separates compute from storage. This is a game changer. It means you can have this one massive centralized place for all your data. Think something like AWS S3. And then you can spin up or shut down your compute clusters whenever you want. Got a huge analytics job? Scale up your compute power. Job's done? Scale it right back down to save a ton of money. And all of that happens without ever messing with your actual data storage. It's all about that cloud elasticity and flexibility. Okay, so we've seen the big picture, the cluster. Now we're going to zoom way in, right down to how the bits and bytes are actually laid out on the disk. Because if the cluster is all about parallelism, this next part, kilometer storage, is all about pure, raw efficiency. Honestly, this is where so much of Vertica's speed really comes from. So traditional databases, you can think of them like a spreadsheet. They store data in rows. Now imagine you have a table with, say, 100 columns, but your query only cares about one of them, maybe the average sales price. A row-based database has to read all 100 columns for every single row just to throw 99 of them away. It's so wasteful. Vertica completely flips that on its head. It stores all the values for column A together, then all the values for column B, and so on. So when your query asks for that one column, it reads only that data. The amount of disk I/O it saves is just massive. And Vertica takes this columnar idea even further with a concept called a projection. A projection isn't just the column itself. It's a physical, optimized copy of a set of columns from your table. And here's the key. It's pre-sorted and compressed specifically to make your most common queries run lightning fast. Now, there's a trade-off here, right? If you create a lot of projections, you're using more disk space because you're storing multiple copies of the data. But the payoff is a gigantic boost in query speed. It's a very deliberate choice. Trade some storage for a whole lot of performance. And this image right here shows you just how powerful that pre-sorting is. In this example, the data is sorted by date. So when a query comes in asking for something from 2006, Vertica doesn't have to scan everything. It knows exactly which physical blocks on the disk to go read. It just jumps right to the data it needs. That's a huge performance win. And here's where it all clicks together. Vertica takes these super optimized, sorted projections, breaks them up into pieces or segments, and then it spreads those segments across all the nodes in the cluster. So now you've got both of these powerful ideas working in perfect harmony. You have the efficiency of columnar storage on each individual node, and you have the massive parallelism of MPP working across the entire cluster. It's the best of both worlds. Okay, so we've looked at the static parts of the architecture, the cluster, the storage, but what happens when you actually hit enter on a query? Now we need to look at the brain of the whole operation, the query optimizer. And this quote from the Vertica team really says it all, because Vertica's storage and its distributed engine are so different from a traditional database, they couldn't just use a generic off-the-shelf optimizer. It just wouldn't have worked. It wouldn't know what to do with projections or columnar data. So they had to build their own from the ground up to really take full advantage of their own unique architecture. And believe me, this is not a simple process. The optimizer is like a grandmaster chess player. It looks at your SQL query, and then it considers all the different projections it could possibly use. It explores literally thousands of potential execution plans, and for each one, it's doing this complex cost-based analysis. It's weighing the cost of everything, reading from the disk, using the CPU, sending data across the network between nodes, all to find the one single absolute fastest path to get you your answer. Okay, great. So the database is highly optimized. But what about in the real world, where new data is constantly flooding in? How does Vertica keep up that peak performance? Well, that brings us to our last piece, a really critical and honestly often overlooked background process. Let me introduce you to the tuple mover. You can think of it as Vertica's automated, tireless janitor, or maybe a librarian. See, when you load new data, it first goes into a temporary, write-optimized holding area. This is great for getting data in fast, but that data isn't sorted or compressed for analytics yet. That's the tuple mover's job. It works quietly in the background, taking all that new data, meticulously compressing it, sorting it, and merging it into the main read-optimized store, the ROS. That's where all those super efficient projections live. And this quote from the administrator's guide really drives the point home. This isn't some optional feature you can turn on or off. It is fundamental to how Vertica works. The tuple mover is what ensures the database doesn't get slower over time as you add more and more data. It's constantly housekeeping, keeping everything in that perfect, optimized state ready for the next big query. So when you put it all together, from the MPP cluster that divides and conquers the work, to the columnar projections that slashes disk I/O, to the custom optimizer that plays chess to find the smartest path, and finally, the tuple mover that keeps everything pristine, you see that every single layer of Vertica is built for just one thing: speed at scale. It's about getting answers from massive datasets incredibly fast, which kind of leaves us with a final fascinating question to think about, doesn't it? When your engine is this fast, maybe the bottleneck isn't the data anymore. Maybe it's the questions we're asking of it.